Hey guys, we're going to look at how we do point-slope equations from graphs. If I have the graph, can I find the right equation for it in point-slope form? Remember, point-slope, it gives us our point that is on the line, and it gives us the slope of the line, right? So when we look at our equation, we know that the m is our slope, and the point that's given is in that x1, y1. And remember, it's opposite from the equation because it's subtracting in our formula. Right? Okay, so look, all you do is you find the slope and then we check the point. You guys are slope masters at this point. So let's look at our first example. Okay, I'm going to find 2 points. Remember, if we do the point method, it avoids scale issues on our graph. Okay, so I'm going to choose 0, 1, and then I have this 3, negative 1. Right, so we're going to stack it. This part should feel comfortable at this point. We've been doing slope for a while. So change in y. 1 to negative 1, we went down 2. Change in x, 0 to 3, we went up 3. Okay, so slope is change in y divided by change in x. Change in y, negative 2, divided by change in x, which is 3. Don't flip it. Okay, we want to make sure that's simplified. I'm going to leave it as a fraction. That's my slope, the m value. So I can look at my equation choices, right? We're seeing A, B, C, and D. We're choosing which one of those equations represents the blue line, my graph, right? That linear function. So I look at my m value. Since I know what my slope is right now, I'm going to use that to help me. By knowing that it's negative 2/3, okay, the first one says negative 3/2. That's the wrong slope. Negative 2/3, okay, that's good. Negative 2/3, that matches. Oh, positive 2/3, nope. Okay, so it's either B or C. This is where reading the equation helps us know if it's correct. We have to know what's the point given in each of those equations. So when I look at B, remember we tell our brains x1, y1, because that's the order of the ordered pair, and it's opposite of the equation. If you need the proof, watch the other video, okay? So negative 3, positive 1 is the point in this equation for B. That tells me that this equation, negative 3, 1, is a point on that equation. So I go negative 3, positive 1 is over here. But I'm looking, that's not on my blue line right there, so it can't be B. B doesn't represent this function. It's a different function, okay? All right, so then let's look at C. So I'm looking at my x1 value, my y1 value. It's opposite. So it's actually positive 3 and negative 1. Positive 3 and negative 1. Okay, so I go and plot that. So I go to positive 3 for x down to negative 1. Hey, I already graphed that. It is on the graph, so it's C. Right, so that's what we're looking for. Again, B was wrong because that point was not on the graph. Since these are my notes, I'm going to write that down. Okay, C is the correct equation because it tells me, hey, I have this point, and then my slope is negative 2, 3. So if I go down 2 over 3, there's another point. If I reverse it, up 2, back 3, there's another point. Up 2, back 3, there's another point. Up 2, back 3, right? So that's what the equation tells me, is I can plot it, and it will give me my line. All right, let's do it one more time. Find the slope. So we have 2 points, so I'm going to take 0, 5. And I'm going to take this one, which is 2, 15. Okay, remember the 2 points helps you avoid scale issues. Look at my y-axis. It's counting by 5s, and my x-axis is counting by 2s. Okay, if I use 2 points, I won't do something funky with my slope. Right, so stack my points and find the change. Change in y. So 5 to 15 is positive 10. Change in x, 0 to 2, we went up by 2. All right, so change in y divided by change in x is going to be 10 divided by 2, which simplifies to 5. That is my slope, my m value. So I go and look, and I'm like, oh, hey, the slope's the same in every single equation. Okay, so now it's, do I know how to read the point? Can I read the point? All right, so first one, x1 is actually positive 6, y1 is positive 25. So the point on this first one is 6, 25. So I'm going to go plot that. Maybe I'll do it in a different color so my brain is like, what's going on? So over 6 up to 25. Oh, that's not on my blue line. That is not the right equation for this graph. It's a different graph. Okay, let's look at the second one. So x1 is over here. It's opposite, so that's -6. And then y1's over here. That's actually -25. So I go plot that. So go to x is -6, go down -25. Hey, look at that, it's on there. Sweet. Okay, so that one works. So I'm thinking B, but I'm just going to double check all the other ones. Okay, so x1 on C, that's actually 25 and +6. So 25 on my x-axis isn't even there. It would be out here somewhere. +6 for y. So this would be somewhere out here. That's not on my graph. Okay. And then on our last one, we have that would actually be -25 for x1 and then -6 for y1. Okay, so I'm looking and seeing, does that fit on here? -25 would be out here somewhere up to, down to -6. That's nowhere near my blue graph right here, so it's not that. Okay, just verifying that those are different equations. B is the only equation that works for this graph because my point, -6, -25 is on the line. And then I go up 5 over 1, up 5 over 1, up 5 over 1, and I would keep landing on my graph. Okay, that's how you do point slope equations from graphs. Find the slope and then know how to read the point.